Dearest grade 12, in this series of videos I'd like to cover the topics on organic chemistry, the reactions that you are required to master in the CAPS syllabus. So, organic reactions. The first reaction I'd like us to look at is the combustion or the oxidation reactions. They play an important role in our lives as they are the reactions that gives us a lot of energy. So our internal combustion engines use organic compounds or hydrocarbons as their fuels. So we are going to look at the reactions of alkanes. Those are the saturated hydrocarbons with the general formula CnH2n+2. Then we will also look at the unsaturated hydrocarbons and their reactions, the alkenes, with their general formula CnH2n. And lastly, we'll look at one example of the alkynes, also unsaturated hydrocarbon with the general formula CnH2n-2. Now, in all these reactions, they are exothermic reactions and they release a lot of energy, makes them very useful. So the change in enthalpy for all these reactions is negative because they are exothermic reactions. My first example would be methane with the formula CH4. Oh, I haven't told you the secret yet. Whenever the alkanes reacts in the presence of oxygen, which is a gas, it will produce carbon dioxide, a gas, and because of all the heat released, it will make water vapor, which is also gaseous. Now, the secret is out. The same rule applies to the alkenes. When they oxidize in the presence of oxygen, they will form carbon dioxide and water vapor. Now, the alkynes follow the same rule. Oxygen reacting with an alkyne will give us carbon dioxide and water vapor. So now my secret is out, and we just need to do a few examples in order to check our balancing ability. So when methane reacts with oxygen, methane is a gas, reacts with oxygen, it will make carbon dioxide and water vapor. To balance the equation, I've got one carbon on the reactant side and one carbon on the product side. I've got 4 hydrogens on the reactant side, I've got 2 on the product side. So to make it 4, we multiply the waters by 2. The oxygen, I've got 2 on the reactant side and 4 on the product side, so we need to multiply the oxygens by 2. So our reaction is balanced if one methane molecule reacts with 2 oxygens to give 1 carbon dioxide and 2 water molecules. My next example, I'm going to use butane. Butane is the alkane with 4 carbons. So if we follow the rule, there will be 10 hydrogens in this reaction. Butane is also a gas. From pentane onwards, for a few hydrocarbon alkanes, they will be liquids. So butane and oxygen will give us fire and carbon dioxide and water vapor. Right, to balance this equation, I always say it's easier to erase a mistake or to figure out things if you use pencil. I've got 4 carbons on the reactant side. I need 4 on the product side. I've got 10 hydrogens on the reactant side. I need 10 on the product side, so we multiply by 5. Now there's something strange here because I've got 8 and 5, that is an odd number of oxygens. That's 13 oxygens, but 13 times 2 is 26, so 13 over 2 times 2 will be 13, but we don't use fractions in balancing equations. So what I'll do is I'll write my 13, but then I need to double up on all these reagents here. So that will give me 8 carbons and 10 waters. So to conclude here, 2 butene molecules will require 13 oxygens, and it will give me 8 carbon dioxides and 10 water molecules. To move to a few examples of the alkenes, I'll use ethene. C2H4 and oxygen will give me carbon dioxide and water vapor. To balance the equation, we need 2 carbon dioxides and 2 water molecules to balance the hydrogens. Then for the oxygens, we've got 2 and 2, which is 4, so multiply the oxygen by 2 to get 4. Next, I'm going to use propene as my example. So C3H6 plus oxygen will give me carbon dioxide, and I'm deliberately leaving the gases out, the symbols for gas, because you know that they're all gases now. And H2O. So to balance the carbons, I need 3 carbon dioxides. To balance the hydrogens, we need 3 waters. To balance the oxygens, I've got 6 and 3, that's 9 oxygens, but it should be 9 over 2, so I know I must multiply all by 2. So 2 propene will react with 9 oxygens to give me 6 carbon dioxide and 6 waters. The last reaction I'm doing is a reaction used in industry. It's called the oxyacetylene flame. And it's used in arc welding. So I'm using ethine. That's where the acetylene comes from. It's C2H2, and oxygen will give us carbon dioxide and water. So we have to balance the carbons, 2 carbon dioxide molecules, and to balance the hydrogens, they're balanced, so we have 4 and 1, that's 5 oxygens, but it's 5 times 2, so we need to multiply all these by 2. There we have the balanced equation. This reaction is extremely important, as I've said, because this flame reaches temperatures of 2800 to 3000 degrees Celsius, and that is why they can use it in welding. Thank you for watching the video. The next video will be on the addition reactions of organic compounds.